Hello friend, myself Rajendra Mahajan presenting my video on Fourier transform. Example, find Fourier cosine transform of 1 upon x square plus a square. Once again I will repeat that question. Find Fourier cosine transform of 1 upon x square plus a square. Watch the video up to end for better understanding. Fourier cosine transform is given by formula is known formula for all of you. It is fc lambda is equals to root 2 by pi integration from 0 to infinity f of u into cos of lambda u du. Substituting the value of f of u as 1 upon u square plus a square, it becomes square root of 2 by pi integration from 0 to infinity 1 upon u square plus a square cos lambda u du. We call this as equation number 1. Then that integral we call as I of lambda as integration from 0 to infinity 1 upon u square plus a square cos lambda u du as equation number 2. Then differentiating this equation 2 with respect to lambda, left hand side we get I dash of lambda. On right hand side there are two variables, therefore derivative is a partial derivative dou by dou lambda of integration from 0 to infinity 1 upon u square plus a square into cos lambda u du. Then using differentiation under integral sign technique, that is DUIS technique, we can interchange that two operators. Therefore we get the value of I dash of lambda as integration from 0 to infinity dou by dou lambda of, the term is cos lambda u divided by u square plus a square with respect to u. Value is integration from 0 to infinity, derivative of cos is minus sine lambda u, chain rule, derivative of lambda u with respect to lambda is u, and whole divided by u square plus a square, and then its integration with respect to u. Equation number 3. Multiplying and dividing equation 3, right hand side of equation 3 by u, we get I dash of lambda is equals to I dash of lambda is equals to integration from 0 to infinity, that u into u it becomes u square with minus sign, sine lambda u divided by u square plus a square into that u, and its integration with respect to u. One more rearrangement, adding and subtracting a square, minus sign outside, integration from 0 to infinity u square plus a square minus a square, so that no change in the value, only form we are changing, and divided by u square plus a square multiplied by sine lambda u divided by that u, and then its integration with respect to u. Dividing separately by u square plus a square, we get minus integration from 0 to infinity 1 minus a square upon u square plus a square in sin lambda u upon u, and then its integration with respect to u. Multiplying inside, we get first integration as 0 to infinity sin lambda u upon u lambda, it is u, sin lambda u upon u, small correction, sin lambda u upon u du minus a square upon u square plus it is sin lambda u upon u into u square plus a square with respect to u. It is equals to minus the value of first integral is pi by 2 using Laplace transform theorem, division by technique. Second term as it is, no change. Link for that video I will provide in description box. Please watch that video, how the value is obtained as pi by 2. Equation number 4th. Since the reason is integration of sin at upon t between limit 0 to infinity, value by Laplace transform is pi by 2. Using Laplace transform technique, value is pi by 2. This step is very, very important. Then again differentiating equation 4 with respect to lambda. We get I double dash of lambda dou by dou lambda of that right hand side of equation 4. Therefore, write down that term as it is, minus pi by 2 minus a square integration from 0 to infinity sin lambda u divided by u into u square plus a square, and then its integration with respect to u. Bracket close. Derivative of constant term is 0. Minus minus it become plus, a square outside, integration from 0 to infinity. It is dou by dou lambda of that integral. Small correction once again. It is dou by dou lambda of integral from 0 to infinity sin lambda u upon u into u square plus a square with respect to u. Then using differentiation under integral sign technique, that is DUIS technique. This is that correction. Then using DUIS technique, add double dash of lambda a square integration from 0 to infinity, derivative of that sin lambda u with respect to lambda divided by u into u square plus a square, and then its integration with respect to u. A square as it is, integration from 0 to infinity, derivative of sine is cos lambda u, chain rule, differentiation of lambda u with respect to lambda is u, and divided by u into u square plus a square as it is, no change. Its integration with respect to u, u get cancelled, and therefore we get the value of I double dash of lambda as a square integration from 0 to infinity of cos lambda u upon u square plus a square. But this integral is nothing but I of lambda. From equation 2. And therefore, using equation 2, we get the value of I double dash of lambda as a square into I of lambda. Transferring to left hand side we get I double dash of lambda minus a square I of lambda is equals to 0. Converting in symbolic form, it is d square minus a square into I of lambda is equals to 0. Second order linear differential equation whose auxiliary equation is d square minus a square is equals to 0. Solving it for d, we get the values of d as plus minus a, two real and different roots, and therefore complementary function cf as c1 e raised to minus a lambda plus c2 e raised to a lambda. And the particular integral is 0 as right hand side of that equation is 0. Then complete solution is sum of these two, cf and pi. Therefore, complete solution is for I of lambda. Cf is c1 e raised to minus a lambda plus c2 e raised to a lambda. Pi is 0. We call this the equation number next, that is fifth. Differentiating this with respect to lambda, we get I dash of lambda as minus ac1 into e raised to minus a lambda plus ac2 e raised to a lambda. Equation number 6. Then in this equation 5 and 6, substitute lambda is equals to 0. We get I of 0 is equals to c1 e raised to 0 plus c2 e raised to 0. But e raised to 0 is 1 means it is c1 plus c2 as I of 0. And I dash of 0 as minus ac1 into e raised to 0 plus ac2 e raised to 0. Again e raised to 0 is 1, therefore it is minus ac1 plus ac2 as I dash of 0. And this combined we call as equation number 7. Then put lambda is equals to 0 in equation 2 and 4. This step is very, very important to get the values of I of 0 and I dash of 0. From 2 we get I of 0 as integration from 0 to infinity. Substituting lambda is equals to 0 in that integral. That term becomes 1 upon u square plus a square cos of 0 as lambda is 0. And value of cos 0 is 1 means that integration from 0 to infinity of 1 upon u square plus a square with respect to u. Using standard result of integration, integration is nothing but tan inverse of u by a whole divided by a, limit from 0 to infinity. 1 by is we take outside. Upper limit tan inverse of infinity minus for lower it becomes tan inverse of 0. But the value of tan inverse of infinity is pi by 2 and tan inverse of 0 is 0. therefore minus 0. And therefore that value is pi upon 2a is the value of I of 0. And from fourth we get the value of I dash of 0 as minus pi by 2 plus a square integration from 0 to infinity. Substituting lambda is equals to 0, we get sine 0 upon u into u square plus a square. And its integration with respect to u. As sine 0 is 0, that term becomes 0, and therefore value is minus pi by 2 only. Substituting that two values in equation 7, we get C1 plus C2 is equals to I of 0, but value of I of 0 is pi by 2a. Therefore, first equation is C1 plus C2 is equals to pi upon 2a, and the second value is minus AC1 plus AC2 is equals to I dash of 0, and the value of I dash of 0 is minus pi by 2. Then solving these two equations simultaneously. Once again, I will write down that equation. First one is C1 plus C2 is equals to pi by 2a. And second equation is minus AC1 plus AC2 is equals to minus pi by 2. Multiplying first equation by a and second by 1, we get AC1 plus AC2 is equals to pi by 2. A get cancelled. And second as it is minus AC1 plus AC2 is equals to minus pi by 2. Then adding these two equations, first term get cancelled. AC2 plus AC2 we get 2AC2, and the sum of right hand side term is 0. We get C2 as 0. Substituting that value in first, we get the value of C1 as pi by 2a minus C2, but C2 is 0. The value is pi by 2a. Substitute this in equation 2, we get value of I of lambda as pi by 2a e raised to minus a lambda, and as C2 is 0, second term becomes 0. Using this in first, we get the value of Fourier cosine transform as fc lambda as square root of 2 by pi as it is, no change, and into I of lambda. I of lambda value is pi upon 2a into e raised to minus a lambda. Once again rewriting it, 1 by a outside constant term, and the remaining term is square root of pi by 2 multiplied by e raised to minus a lambda is the required value of that cosine transform. Please like my video, share it, as well as subscribe to my channel, and to receive the notification please press the bell icon. Thank you. Thanks for watching.